Hello, everyone. Good afternoon. Welcome, and thank you so much for taking the time to join us for today's What's New webinar, Fork and Merge. My name is Ryan Hallback, and I am a Principal Intelligence Analyst here at the Vertex Project. And I'm joined here today with my teammate and partner in crime, Mary Beth Lee. And today we're going to talk to you a little bit about the Synapse Fork and Merge workflow, which is a workflow that we created here at Vertex within Synapse to help analysts like us easily perform tasks like training, testing, and rapid analysis within our production Synapse system. So what we're going to cover today during this webinar is just give you a quick background into Synapse for those of you who may not have been exposed to our system just yet. Go over some common workflow challenges that we've encountered through our years of doing analysis, and then talk about our fork and merge workflow that we created to address some of those challenges. Then go over some use cases and case studies where you can actually use the fork and merge workflow within your day-to-day analysis. But before I talk about fork and merge, let me start off by giving you a quick background into Synapse. So at Vertex, we are a company of developers and analysts. We wanted to create a system that we can use to allow us as analysts to perform every stage of the intelligence lifecycle within the same system. So we wanted to plan our research and collect data and process that data and perform analysis and reporting all from the same place. Our team wanted the ability to easily work with each other and collaborate, represent data from any domain, not just the threat intelligence space, and interact with that data in a way that allowed us to easily ask questions of the data, capture our analysis and assessments. So we created Synapse, which is a system that is built upon a hypergraph technology. So that means we can represent all data, any data, and their associated connections and relationships. We also created a data and analytical model and a custom query language. And we integrated all of that with services that facilitate things like data ingestion, enrichment, analysis, and automation. So we like to say that Synapse uses data, platforms, and teams to allow us to collaborate and perform cross-domain analysis. So great, we came together and we created Synapse, which was our platform that allowed teams to come together and perform analysis and store their production intelligence, their corporate knowledge. But in designing the system, what we realized was from our prior experience that we needed the ability to analyze data within a production environment safely without the risk of contaminating production data. So specifically, we wanted to be able to ingest and enrich raw data, analyze that data, leveraging historical context and assessments that existed within the graph, and then build upon those existing assessments and build our knowledge without negatively impacting our production data. Because it turns out that analysts do make mistakes. And like software developers and report writers, we want to reserve the right to change our mind and improve our work. So where you're a developer or a coder, you have a development environment that you can work within to test and debug your code before you deploy it to your production environment. And if you are a report writer, you have the ability to create drafts of your report before you publish it online. But as an analyst, what do I have, right? Where is my test environment? Where is my analysis scratch space? We didn't have that. We didn't have a scratch space or a so-called production sandbox where we could perform our analysis safely. And because of this, this presented several challenges for us analytically and just for whatever workflow we wanted to create. So for an example, if I wanted to conduct analysis within a production system and have my teammate Mary Beth review my findings before I pushed it to a customer to be consumed, I couldn't. What I also encountered as a trainer and as a trainee was that it was difficult for me to train within a realistic training environment, specifically because we wanted to create training that matched our standards, one that mimicked our operational environment. And that would be time consuming to set up and really not feasible. We wanted to be able to train our analysts using real data and lots of it using our actual workflows and our processes. What I also encounter as an analyst is I also support IR engagements, at least I have in the past. And so I needed the ability in those instances to be able to perform rapid analysis, especially when I'm supporting an IR. Whenever you're supporting an IR, data is coming in quickly, and it's going to come in on an ongoing and continuous basis. You just don't get data all at one time. And because of that, I wanted the flexibility to represent that data as they come in, and optionally change the data and assessments in a safe place, right? As I got more data to support my analysis. Another thing is that as an analyst, a good problem that we have is that we have access to a lot of data. But because we have access to a lot of data, sometimes that can muddy the waters and it can muddy our analysis, and it can cause a low signal to noise ratio. So it's helpful if I can evaluate that data before I push it into my production system. And because I have a lot of data that I work with, what we love to do is automate, automate, automate. So we want to be able to process and analyze whatever data we can using that automation and those workflows. But it's best if I can test that within a production environment, just to make sure that when I deploy it, it'll work as expected. To address these challenges, since we didn't have our own sandbox or our own scratch space, what we did was we created our own workflow that was native to Synapse. So specifically, what we did was created a workflow that gives analysts the option to create a temporary scratch space in their production environment to accommodate any dynamic and temporary analysis needs. The workflow that we created is called the fork and merge workflow. So what I want to do is just introduce you to it and tell you about its components and let you see what it looks like when it's in use. In Synapse, the fork and merge workflow is primarily enabled by four main components in operations. And to help you understand what that looks like, I'm going to address each of these components individually. So first, the first thing we have within this workflow are layers. Layers are simply where data lives. It's where the data are written and where they're deleted from. Within Synapse, you can separate data if you want to using layers based upon any segmentation needs that you have. For example, maybe you have data sharing agreements that you need to adhere to with third parties or different partners, or maybe you have data retention restrictions or requirements that you need to adhere to as well. This is where layers come into play. Then in addition to layers, we have views. In order to access the data in the layers, to create or manipulate that data, you must have a view. And a view is simply an order set of layers, one or multiple layers, however you see fit, where the bottom layers are read-only, and that top layer, indicated in green in the icon, is writable. So views effectively allow you to unify the data in your view, and fuse data, and really inspect that data from any vantage point that you need that aligns with your analysis or a given analysis task. So to give analysts the option to work safely with a set of data of their choice in a production system, we allow analysts to create a fork of a desired view, giving analysts a scratch space, and then from there you can optionally merge or keep the data that was created in that scratch space. So within our fork and merge workflow, what happens is when you create a fork, what you're doing is you are creating a read-only copy of an existing view. And then when you have that read-only copy of that existing view, you then create a writable layer on top that you own and control. What that does is it gives us as analysts unfettered access to the underlying data, the existing data and assessments that we can use for our analysis, and it gives us a scratch space where we can work freely to add data to the system, but most importantly, keep that data separate from our production data. And so then when we're done, what we have is the option to take all of those edits that we made and either merge them down, full take into the parent view that we forked from, or we can merge a subset of that data down into our parent view, or just throw all of our changes away altogether and discard them. To further explain this workflow, let me take you through a simple visual. So let's say, for an example, we have a view named IR in our Synapse instance, and that this view is comprised of two layers. At the bottom, we have our shared intel layer that is comprised of two nodes. And at the top, we have our IR data layer, which just has one node and is active and writable. Now let's say we use this view internally to juxtapose any analytically relevant IR data collected from our client engagements with our internal threat intelligence body of knowledge. Now let's say we need to kick off a new IR. What would we do? Do we want to actively work within our production data and risk contaminating that data? Or do we want to smartly create a temporary layer where we can work from freely? We're going to choose the second option, where we're going to add data to a temporary layer within that view so that we can rapidly add data to that system, analyze that data, leveraging our existing threat intel corpus, and then optionally merge or discard any engagement data that we need or don't need. So to create an isolated environment that we can work within, what we do is we can create a fork view of the IR view. When we create a fork, essentially what we're doing is we are creating a copy of the view that we're forking from. So in our example, it will be the IR view. And when we do that, what we get is the two layers that are contained within that view and all of its associated data, all of the tags, all of the nodes, the node properties, everything. Then once we have that copy, then we get a blank writable layer directly on top of that IR view. So now we have our scratch space that we can work within. And we have that scratch space all while being able to view the data contained within that IR view. So what does it look like when we want to come and now add data to this fork view? From the image, what you can see is when I added some nodes to the graph, the only layer that changed was that top writable layer. And specifically what happened was I added a set of nodes on top. I added some red nodes, which those indicate tags or new context that were added to existing nodes. So those nodes previously existed in that IR view. And then I also added a green node in that writable layer. And that represents a new node. So it was a node that did not exist in those bottom two layers. And what you can see here is if you look at the layers on my left, and if you look at the screen being projected on that laptop, I have a graph being projected on the laptop that actually changed in real time. Because that laptop image now represents the composite view of all of those layers combined. So when I'm done making edits, when I'm done performing my analysis, what do? I can merge all of this data down into that production IR view. I can take some of the tags or nodes that I created, or I can just store it all the way. In this example, we're going to keep all of our data. So when we merge the data down, what happens is the data in the writable layer gets written down to the data in the IR layer. I'm sorry, it gets written down to the layer, the IR data layer specifically. And it makes that data immediately available to anyone who has access to that view. Then that writable layer is thrown away, and now I have an updated view. So when it's all said and done, we have an updated IR view that contains the initial IR data that was there when we started, and any data created in that temporary writable layer that we wrote down, unless, of course, we chose to delete some nodes. So to recap, what did we just do? In a pretty short order, we were able to stand up a test environment within our production environment, take data from an existing IR view, create a fork of that view, and obtain a temporary writable layer on top. Then we did some analysis, added some context. We added some context to existing nodes and created new nodes. And then when we were done, we easily merged that data down into our IR view and modified the view. This is powerful to me as an analyst because it's fast, it's not computationally expensive, and most importantly, it provided me the analysis workflow that I needed in real time. So there are several use cases that we have with the fork and merge workflow. If you need to, collaborate with your peers and do some analyst training, for an example, you can use the fork and merge workflow to create a workspace and provide it to a junior analyst. Allow them to analyze data and annotate it, and then go in and review their edits and give them feedback, and then choose to accept or reject those changes as you see fit. You can also use the fork and merge workflow to codify your own workflow. So if you want to test out some automation before you push it to your production Synapse instance, you can as well. So aside of those use cases, what we're going to do now is switch it over to MB, where she's going to walk you through 3 case studies using the fork and merge workflow. First, she's going to walk you through what it looks like to conduct analyst training using this workflow, then what it looks like to support an incident response, And then after that, codify some of your analysis workflows within the fork and merge process.
So what we're going to do is the first case study we're going to walk through is using forked view for analyst training, collaboration, and peer review. In this case, we're going to pretend that we have a junior analyst. His name is Ozzy. And we want him to use a tool called the file parser to go ahead and practice modeling out a spear phishing email and email addresses, attachments, things that came along with it, and then go through and tag them. And we want him to do it in a forked view because he's new. We don't really trust him. We don't want him to write to our production layer. So we want to give him a scratch space where he can practice. We want him to have the ability to access tools that are in our cortex and also access data that's in our cortex, but we want all of his changes to be contained within his own view. And then as another analyst, I can go through and I can either see his changes, I can share that view with him and I can see his changes in real time, or I can go back and just look at the diff tool, which I'll walk you through. And at the end of when he's done with all of his work, I can go and just review all the changes he made. The way that I'm going to set this up, he doesn't have access to our production layer, so he can't actually merge down himself. But as the senior analyst partnering with him, I can do that merge for him if I decide that his work is good enough to keep. So we're going to go ahead and fork a view from here. Well, first I'll actually show you what I'm going to have him do. So this is a file that's in our current layer, our current view, that I'm going to have him use the file parser on. It's not processed, so if we click the explore button, the only thing that we're able to pivot to are the hashes and the file base, which is actually another hash. So this is what he's going to work on. And I'm going to go up here. I'm going to fork a new view for him. I'm going to call it Aussie training, so he knows where to go. And we'll fork that. Then I'm going to go over to my admin tool, and I'm going to go give him access to this. So I'll add another user, and we'll put Aussie in there. And then we'll give him read-write privileges to that. And there he goes. So we'll switch over to another window here. And here we are impersonating Aussie. This is him on our base layer, our production layer, our fork and merge layer. He doesn't have permissions to do things here. He can't tag. If he tries to, he will get an error. He can't add nodes. Again, if he tries to, he'll get an error. But what he can do, we'll just refresh that quickly so we can get to his training view. He does have full permissions though in the training view. So here he can work a little bit and test things out. So the first thing that he'll do is he'll lift that file bytes node. He's going to right click on it, go to our node actions, and he's going to parse it out. And so the file parser is going to go through and break this out into the spear phishing email and then email addresses that were used to send it, headers, things like that. Made 108 edits on 15 nodes. So we can go to the explore button and look to see what happened. We see a lot more than just the hashes that we had seen previously on the base layer. We can go to scroll to form, and he's going to specifically want to lift that email. And here's the email here. And we're going to pretend that he's already seen this email before. So he's already done his analysis. He already knows what to tag. He's just practicing going through and tagging it as well as using the file parser. But if he was more curious about what this looked like, he could always do some pivoting. He could always, like, hovering over the body on the right-hand side, it will show what the contents of that email actually was. But for the sake of time, we're going to pretend he's already looked at it. So he's going to right-click on it, and he's going to add a tag. The first tag that he's going to add is, TTP phish email. Say that this is the phishing email. We'll go and pivot off of that. And here are the two addresses. The first was the target, that was the recipient. So he's going to right click and add another tag to that. We'll make it TGT for target. And then the second email address is actually the one that was designed to look like it was sending it. So we'll tag that as the sender. And then Ozzy is going to scroll down and he's looking for the attachment. And it looks like there's an attached file. So he'll pivot off of there. And this is the actual bytes of the file that was attached. So he's going to tag that with something, and it will be payload. And he'll apply that tag there. And let's say that he forgets, or he's a little bit, I don't know, he decides that he's going to try and merge himself. And he can go ahead and click onto this merge down. He'll get a confirm button, but then he'll throw an error. He is not allowed to merge down. We safeguarded him off from the production layer because he is still a junior analyst who's in training. So he's done everything that he can do right now. He has the ability to use the file parser to make nodes, and he has the ability to tag like he did. So we'll go back over to my window, and I can see all those changes coming in real time. So if I go and I pivot off of that same file that he broke out, I can see that he broke it out with the file parser. I can go to the email, see that he tagged it. I can also make changes because we're sharing this view. If say this was the wrong tag, or he typoed it or something like that, I can go and delete it and tell him like, try it again, or correct it for him even. And I can walk through, there are a couple different ways I can see the changes that he made. I can either walk through using the explore button the same way that he did, or if I want to see like a summary of the changes that he did, I can go up to this diff tool, which I talked about a little bit previously. And I can go and see, it'll show me everything that's different in this view from the underlying view. And here there's a lot going on because he was using the file parser, and the file parser broke everything out, made a bunch of nodes, and then it populated all those nodes with different node properties. So for what I want to check, I just want to check to see the tags that he put on. So I'm going to filter by tag, add, and then I can just go back down and see he got the TTP fish target on the recipient email. He tagged the sender. He tagged the payload that was attached, and he tagged the email. And so if I decide that he did a good job, I can go ahead and merge this down, and then there's no duplication of effort. He doesn't have to go into the underlying production layer and then redo all the work that he just did. We can just merge it down and his changes will stay. Alternatively, if he was a little bit too creative, and it's not really worth trying to go through and correct all of his mistakes here, I could just delete the view. I could just wipe it completely, create a new view, and have him start over. In this case, he did a good job though, so we can go ahead and we can merge it down. And then, so now we're back in that underlying layer, and we can see the node at all of his changes carried over. We see your email again that he had tagged. So all of the things that he did just got pushed down when we merged. And so now they're in our production layer. So that was an example of how we can use fork and merge for creating a view, creating a scratch space that you can use for analyst training, for collaboration if you're having a junior analyst partner with a more senior analyst, or if you're even having just two analysts partner together to work on something, and also for peer review. You can use either follow along as they're tagging and making changes, and you see those changes come in real time. You can use the diff view to see like a summary of their changes. Either way, you can use fork and merge to create scratch space where all of your changes are contained until you're ready to merge them down. Everything is protected so that you don't make any changes that are kind of like inadvertent, or things don't get pushed down to that underlying layer. You have to have permissions to do that. So the second case study that we're going to do is going to be for DFIR, case management. And in this, we're going to pretend that, like I'm an IR team that's looking at a host that there is some suspicious activity. And so my task was to go and triage a bunch of files that were pulled from this host. They were all kind of yanked over from the time that we saw something weird going on. So not all of these files are related to the incident. Some of them are probably going to be benign. And so I'm going to use a forked view to triage these because I don't want to keep the files that aren't related. I only want to keep the ones that are actually important. And so rather than import all of the files into our production layer to go through them, I'm just going to do it in a forked view and then only merge down the files that are relevant. So I'm going to go ahead and fork a view, and we'll call it like cert for cyber incident response team, whatever. A fork a view, and then I'm going to upload a file that contains a zip file that contains all of these files that I was looking at. There are different ways that you can get files in here. You could use like the ingest tool. You could use, if you had like a SIEM solution that was connected to a power up, you could do that. For this, I'm just gonna upload zip file. So there's my host samples uploading. And when it uploads, I'm going to go ahead and use the file parser again, actually, to break it out. And there we are. I'm just going to do that through node actions. So right click down to actions, and I'm going to go to the file parser, and it's going to parse those out. And 439 edits on 92 nodes. And we can go and hit explore. And I want to go to see the subfiles, so all the files that were contained within here. And I can go ahead and pivot on these guys. So I'll highlight them all, hit the explore button to pivot. And what I want to do is, I have the file bytes of these now, but what I want to do is send them through a service that we have called the NSRL service. And it's going to match up the hashes with hashes that it has, that the NSRL service knows about. So to do that, I actually have to submit their SHA-256 hashes. So I'm going to pivot once more to get to those, and then go to scroll to form. And the first thing I notice when I lift up the SHA-256 files is that some of them are already color-coded, which is a workspace preference that I have. If something has certain tags, I assign it to certain colors. So for green, for me, it's actually assigned to any hash that has a rep.nsrl tag on it. So some of these are already tagged. And the reason that we're seeing this in our forked view is because this is actually data that exists on that underlying layer. These were things, so these 3 hashes were actually something that are in our production layer that have already been processed. And so I'm able to see that context when I'm working in my forked view. So I know that at least some of these are known, that the NSRL service knows about at least some of these hashes. And we'll go and just right click again, and we'll just pipe these all to the NSRL service just in case. And it looks like it recognized a bunch of them. The 2 files that it hashes that did not recognize, one of them is actually our zip file. We're not going to worry about that. The other one we're going to go look at a little bit more closely. I actually want to send that to our virus total service to see if VT knows anything about it. So again, I'll right click, go to actions, and go to VT enrich. And we'll have that run. And then we'll pivot to that file. So it looks like it brought over some tags. It's a self-extracting RAR file. And we'll hit the explore button to see what we can pivot to from here. And if we go up to scroll to form, I tend to use this because it's just a little bit easier to see like an overview of all of the nodes that are attached to this, this node, in this case, this file bytes node. It looks like we have P resources, section, subfiles. It looks like inet DNS request. So there's some network communication going on, which probably is not a good sign. Inet flow, ITAV file hit. So it looks like 78 of the AV engines that VirusTotal has access to said that this file detected as something. There's a lot of Trojan names in the detection names, generic. So I'm not sure exactly what this is. It looks like a lot of the detections were generic, sorry. But this is, either way, this is probably not a file that we really want to have on one of our hosts. And it's probably worth having our either another analyst or a reverser take a look at it and see what's going on. It may end up being related to the incident that we're investigating, or it may not. Hopefully it's not a sign that there's another incident going on. Otherwise, we're not going to have fun with that. So we'll go back to the file bytes node, and I'm going to add a tag here that's just going to flag this file for everyone else so that they know that this is something that we should take a look at. So I'm going to mark it as CNO mal. And then I don't want to merge down everything in this view because there was a bunch of files that I wasn't interested in, right? There were ones that the NSRL service recognized. So what I'm going to do is a selective merge. I only want this file. So I'm going to right click, and I'm going to go to actions and then do merge apply. And this, when I hit merge apply, it's going to merge down this one file byte node. And then I can go and I can manually delete that view and dump the rest of that data because I'm not interested in it. So I'll go ahead, we merge that one down, and then I'm going to go up and delete the rest of this view and all the changes. And we're now back in our fork and merge, our production layer. And if I query this one, so this is the file that we merged down, and you can see it here, and you can see the CNO mal tag. So we were able to keep that one file that we were interested in and get rid of the other ones that we were less interested in. So that was an example of how we could use fork and merge workflow as a way to have a scratch space to triage data. It was we were able to use like some of the tools that we have, like the file parser or like this NSRL service, and also the virus total service that we have. We were also able to benefit from some of the data that was in the underlying view, like the files that we had already processed that were already tagged with that rep.nsrl. This is a very scaled down version of what like an IR incident response like engagement might detail. Like you'd probably be working with a ton more data and with a lot more hosts. But it's a worthwhile example because forking a view is computationally cheap and it's really easy to do. And so if I were actually working a real IR, I wouldn't necessarily need to have like one forked view to rule them all. I could keep, for each little task where I needed a scratch space, I could just keep forking views and merging them down or ditching them as appropriate regarding, depending on what I wanted to do with the data that I had. It's just an easy way to have a scratch space. And so the last case study that we're going to go through is going to demonstrate using fork and merge for workplace or workflow codification testing. In this case, I'm going to test automation, which automation is great because you can do things at machine speed, but unfortunately, if you screw up your automation, you can make mistakes at machine speed. And so that's why we're going to do it in a forked view. I have a YAR rule that is pretty high confidence. It pretty much detects samples of this one family that's called ocean salt. So I'm comfortable creating automation in which any file that matches on that YAR rule gets tagged as cno.mal.oceansalt. The one part I'm a little bit questioning is my ability to actually write that automation. So there's the chance that when I test it, that everything within the cortex is going to get tagged cno.mal.oceansalt. So I'm going to do this in a forked view, and then if it's going to give me the ability to use real tools like our YAR match service, and also real data to test it again. But all of my changes are going to be within the view. So if my automation turns out to be really wrong and apply tags to everything, rather than have to go to Visi and be like, hey, I need to clean up the production layer, I can just delete that view and hide all of the crimes that I've committed in our cortex. Because nothing in that production layer will have been actually changed. It's all contained within my view. So the first thing we're going to do is create this view. So I have a spot to test my automation. I'm just going to name it like Yara. And then the second thing that I'm going to do is go and start putting in my automation that I wrote out previously. And I'm going to use a macro for this. So I'm going to go add a macro. I'm going to name it Yara tag push. And I'll add it in and save. And it's going to apply cno.mal whatever the malware family is that's on that Yara rule node. And it's also going to apply this other tag that's internal review.yara so that I can go and check the results later. I know that these things weren't like manually applied or manually tagged as being part of this malware family, but they're tagged as being a result of this rule. So the next thing I want to do is create a trigger that is going to fire on whenever a file matches on that rule. So I'm going to go just copy this in. And I'm going to name it like push tags Yara match. And then I'm going to write a little description in case I forget or in case somebody else sees it and can't figure out from what the code is or what the storm is what I'm trying to do. And I'm going to have it fire on a node add, and it's going to be when a Yara match node is added. Yeah, because I can't type. Add trigger. I'm going to check. Okay, so it's going to run the macro Yara tag push. And I want to make sure that my macro is Yara tag push. Okay, good. And then I'm going to check my rule that I want to test this against. My cno.mal ocean salt rule. So that's my rule that I'm going to use for testing. And then I have some files that I'm also going to use And these are things that McAfee said were part of the ocean salt family. Not all of these are what we consider ocean salt, so not all of these are going to match, and that's fine. So I'm going to go ahead and pipe these all to our Yarn match service. I'm going to right click, actions, Yarn match, 42 edits on 8 nodes. And so the ones that showed up in red are the ones that had a CNO-MAL tag applied. We can see this one has our CNO-MAL ocean salt and it also has the other review tag. This one too. And it looks like it worked. It looks like our automation got everything. The ones that are not in red are the ones that don't have that CNO tag and also didn't get a internal review tag. So in this case, it looks like the automation worked. If the automation had not worked, I would probably just delete this view and start over and try again, unless it didn't tag anything, in which case it would be fine to keep using this view. But in this case, since it worked, I can go ahead and I can merge down the entire thing because I want to keep these results. These are files that did match on that rule, so I'm happy to keep them in our production layer. I can go ahead and I can merge that down. And so here we are in our underlying view. In our production view, our changes merged down. We have all of our matched files that got the CNO-MAL ocean salt tag and also the internal review tag. So that's an example of how you can use forked views for testing, especially things like automation, where you want to be able to test against real data, but you don't want to necessarily commit those changes. You want to make sure that your automation is working correctly before you change data on the production layer. It gives you, so using a forked view to do that testing gives you like a safe space where you can work and you can make tweaks to your automation and you don't have to worry about changes that you might make to the production data. So these are just 3 examples of how you can use fork and merge workflow. Ideally, it's anything that you would want a scratch space for, anything that you want to have the ability to use your real tools that are in the cortex or data that's in the cortex, but where you might want the ability to have your changes kind of contained until you can review them or you can check them and make sure that they're correct, and then you can merge them down. Also, if you want to use a forked view for triaging data where maybe you need to go through a lot of data and you don't want to keep it all, and you can do a selective merge. Also, any sort of collaboration, whether if you're working with a junior analyst or working with a peer analyst and you both want to work together and do some analysis and then check each other's work and then merge it down. Fork and merge is a good way to have that sort of scratch space. So that's it for us today. Thank you for joining us, and I hope that this was helpful.